This is the explanation for experiment 2, the mouse disturber. At the top, I have a particles array and a mode variable to track which variation we're on. In setup, I've set the color mode to HSB, which is hue, saturation, and brightness, which makes it easier to color the particles based on their speed later. Then I call spawn particles, which just fill the array with 222 new particle objects. In draw, instead of clearing the screen fully, I redraw the background with an alpha of 18 out of 100. That's what creates the motion trail effect. Previous positions fade slowly rather than disappearing instantly. Then I loop through every particle and call update and draw on each one. The particle class is where everything happens. In the constructor, each particle gets a hue map from its index, so they go from purple to teal across the grid. Then I calculate a home position using hx and hy. By treating index as a grid coordinate, the particles start at its home position with 0 velocity. The update method calculates dx and dy, the difference between the particle positions and the mouse, and then gets the distance d using Pythagoras. So if d is under 160 pixels and is greater than 1, the particle is in range. Then, depending on the mode, it calls one of the three force methods. Repel uses pow 1 minus d by 162. That square term is the key. It means particles very close to the cursor get a massive force while the others near the edge barely feel it. After the force, a string pulls them home at 0.04. That constant controls how quickly they return. Velocity is multiplied by 0.82 each frame as damping. Orbit adds two forces, one pulling inward towards the cursor and one pushing sideways perpendicular to that. The sideway one uses negative dy and positive dx, which is the 90-degree rotation of the direction vector, and the 0.6 multiplier on that took the most tuning. It's the ratio between inward and sideways force that determines whether you get an orbit or a collapse. Flock calculates a flow angle using aten2 of the mouse direction, adds half underscore pi to rotate it 90 degrees, then adds a sine wave that varies per particle using this index 0.04 as a phase offset. The offset is what makes each particle slightly different from its neighbors. In the draw method, speed is calculated from the velocity components. That speed value then drives the saturation, brightness, and size. Faster particles are brighter and bigger. If speed is over 3, a short line is drawn behind a particle as a velocity streak.